We're diving into spanning tree protocol protections for your CCNA exam, specifically focusing on PortFast, BPDU Guard, and Root Guard. These features are critical for maintaining a stable and secure Layer 2 topology, and the exam will absolutely test your knowledge of where, when, and why to use each one. Let's start with PortFast. By default, when a device connects to a switch port, STP puts that port through the listening and learning states, which can take up to 30 seconds before it starts forwarding traffic. For a server or PC, this delay can cause issues like failed DHCP requests. PortFast is the solution. You enable it on access ports connected to end devices, and it allows the port to bypass the listening and learning states and transition immediately to the forwarding state. The key exam point here is that PortFast should only be used on edge ports connected to single hosts, never on ports linking to other switches or hubs, as this could create temporary bridging loops. Now, enabling PortFast creates a new risk. What if someone accidentally connects a switch to that port? That new switch could send Bridge Protocol Data Units, or BPDUs, and potentially cause an STP recalculation or a loop. This is where BPDU Guard comes in. It's the essential partner to PortFast. When you enable BPDU Guard on a PortFast-enabled interface, the switch listens for any incoming BPDUs. If a single BPDU is received, BPDU Guard will immediately place the port into an error-disabled or err-disabled state, effectively shutting it down to protect the network. An exam question might present a scenario where a user connects an unauthorized switch to a wall jack, and you need to identify the feature that would automatically disable the port. The answer is BPDU Guard. You must remember that you have to manually re-enable a port that has been put into an error-disabled state. Next, let's discuss Root Guard. This feature serves a completely different purpose. While BPDU Guard protects edge ports, Root Guard protects the core of your STP topology. Its job is to prevent a connected switch from illegitimately becoming the root bridge. You would configure Root Guard on designated ports that face other switches you do not control, or that should never be the root bridge. If a switch port with Root Guard enabled receives a superior BPDU, that is, a BPDU from a switch with a better bridge ID that is trying to become the root, it does not shut the port down. Instead, it places the port into a root inconsistent state. In this state, the port stops forwarding traffic until the superior BPDUs stop arriving, thus protecting the position of your intended root bridge. A common exam trap is to confuse the actions of BPDU Guard and Root Guard. BPDU Guard puts a port in error-disabled for any BPDU on an edge port, while Root Guard puts a port in root inconsistent for a superior BPDU on a core-facing port. For a memorable shortcut, think BPDU Guard protects the edge from rogue switches, while Root Guard protects the core from rogue roots. This helps separate their functions and typical locations in the network hierarchy. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.